Hello students, how are you? Hope so you are well and safe at home. So today on 7th of November, day Saturday for class 11th chemistry, we have the new topic that is balancing of redox reactions. In the last video, we have already discussed about the types of different chemical reactions, redox reactions. We have done the topic of how can we calculate the oxidation number. Clear? Now we start how can we balance chemical redox reactions. Clear? So there are two different methods. One method represents to the oxidation method and second is known as the electron ion method. Clear? So now we start with the electron ion method. Clear? So now we write a chemical equation that represent maybe of ionic phase or that may be of molecular phase. If any of the reaction is given in the molecular phase, so first of all we convert into ionic phases, means each and every compound firstly convert into the ionic phase. Clear? After conversion of molecular to ionic phase, first of all we eliminate all those compounds or those cations or anions which are common in both sides, which are the same type of oxidation number, which are the same type of the charge. Clear? So now we write here a chemical redox reaction. So now we have Cr2O7 2 negative plus FeSO4 plus H ion, Cr3 Cr3 positive, Fe2SO4 whole thrice. So first of all we write here the all given compounds, those are not in the ionic phase, first of all convert all the compounds in the ionic phase. Clear? Cr2O7 2 negative, that is in aqueous condition, it is already present in negative condition. FeSO4 means SO4 contain always 2 negative. This is the sulfate ion. It means this ion contain 2 positive. So Fe plus 2 plus SO4 2 negative plus H ion. This H ion represent to this equation is present in the acidic medium. When we balance any of the equation, first of all we check out this equation in the form of the acidic condition or basic condition. Clear? So in this equation already given here that H ion means this equation carried out in presence of acidic medium. Clear? So H ion represent to acidic conditions. Now Cr3 positive plus 2 Fe SO4 whole thrice means SO4 contain 2 negative. 3 SO4 means there are 6 negative overall and Fe are 2, it means this Fe contains 3 positive. Otherwise we can calculate by the oxidation number. SO4 represent to -2 multiplied by 3, overall charge is 0 and this Fe represent to 2x. Clear? So Fe represent to the x, how many Fe is 2, sulfate ion represent to the -2. How many SO4 is there? 3. Overall molecule is the neutral, that's why we can easily calculate the value of the x. So x is equal to plus 3. Clear? So the ion contain plus 3 charge. Okay? And 3 SO4 2 negative. So now both side, reactant side and the product side, all ions are present. Clear? Now first of all we eliminate, means those compounds which are common in both sides. Clear? So first of all we eliminate sulfate ion and we write the next equation, that is Cr2O7 plus Fe2 positive arrow plus H ion arrow Cr3 positive plus Fe3 positive. There is no need to write here the coefficient of the anions or cations. Clear? So this is the next equation represent to ionic conditions. Now we start the balancing of the equation. In ion electron method, now we solve this equation or balance this equation by ion electron method. Clear? So this equation is balanced by ion electron method. In ion electron method, firstly this equation, this ionic equation firstly convert into the two parts. One is oxidation half reaction and second is reduction half reaction. Means those compounds which have the tendency to reduce itself, that represent to reduction half cell reaction, and those compounds or anions or the cations have the tendency to show oxidize itself, we can show here the next equation, that is oxidation half reaction. Clear? So see here, this chromium represent to +6 oxidation. In this case, chromium represent to the +3 oxidation. You can easily calculate by this method. Means oxygen represent to the -2, clear, and chromium represent to the X. So we can calculate the value of this chromium oxidation, that is +6. Iron represent to the +2, and now in the +3 condition. Okay. Oxidation half reaction. So which compound undergoes oxidized? Fe2 positive convert into Fe3 positive, means ferrous ion oxidized to ferric ion. This ferrous ion that have the +2 charge convert into Fe3 positive, means ferrous ion convert into ferric ion by the oxidation. So first of all we will write here Fe2 positive convert into Fe3 positive. So this is the part of oxidation number. There is no need to balance the elements of the atoms, because both sides the same number of atoms are present of iron. Clear? Next is reduction half reaction. Reduction half reaction means this dichromate ion Cr2O7 2 negative convert into Cr3 positive. Cr2O7, that is dichromate ion. Cr2O7 2 negative is known as dichromate ion. This dichromate ion convert into Cr3 positive. Clear? Now, so first of all we balance the chromium. This side number of chromiums are 2, this side number of chromium is 1. So first of all we write here Cr2O7 2 negative plus Cr2O7 2 negative arrow 2Cr3 positive. Clear? Cr2O7 arrow 2Cr3 positive. We can write here the numbers of each and every equation. Suppose this is the equation number 1. Clear? This represents the equation number 2. This represents the equation number 3, and this represents the equation number 4. Clear? Now after the balancing of the chromium, now we balance this oxygen atom. In acidic medium, oxygen is balanced by H ion and water. If equation is in the acidic condition, it means oxygen balanced by hydrogen ion and water molecule. Clear? See here, how many oxygens are there? 7. It means this side 7 oxygens are less. So we can say that this side we can add 7 molecule of water, because 1 molecule water contain only 1 oxygen atom. So that's why this side means the opposite side of the oxygen, we added 7 molecule of water. Cr2O7 2 negative, arrow 2Cr3 positive plus 7 H2O. Clear? So see here, now dichromate ion, arrow 2Cr3 positive plus 7 H2O. So now both side oxygens are balanced. This side 7 number of atoms and that side 7 number. Clear? But by the adding of water, 14 hydrogen also increases. How many hydrogens are increases? In the product side, that is 14 hydrogen. To balance the hydrogen, this side means the product side, we can edit opposite side number of hydrogen, and that hydrogen must be same according to the product condition. Clear? So see here, it means 14 HIN plus Cr2O7 2 negative, arrow 2Cr3 positive plus 7 H2O. Now you can check both side, all the atoms are same. 14H, this side 14H, chromium 2, this side chromium 2, oxygen 7, this side oxygen 7. Now we can balance charges because this represents ion electron method. So we can balance ion in both sides in this both conditions. Clear? अब हम जितने भी charges हैं उन charges को balance करेंगे. Clear? So suppose this is the equation number 5. In the reactant side, 14 positive and 2 negative. See here. How many hydrogens are there? 14. How many dichromate ions are? Only 1. So 1 dichromate contain 2 negative and 14H contain 14 positive. It means this side, how many positive? 12 positive, because 14 positive plus 2 negative means 12 पॉजिटिव मींस 2 नेगेटिव ने 2 पॉजिटिव को कैंसिल कर दिया और कितने पॉजिटिव रिमेनिंग रह गए 12 पॉजिटिव. सो दिस साइड 12 electrons are less. What is the mean of the positive sign? Positive sign means 12 electrons are less in the reactant side. Now 3 positive and how many chromiums are there? 2. It means this side 6 positive. Clear? It means in the reactant side, in this equation, 12 electrons are less. In the product side, 6 electrons are less. How can we balance these two? If we donate 6 electron in the reactant side, if we donate 6 electron in reactant side, it means both the side number of positive charges will be same. So we can write here 14 H positive plus Cr2O7 2 negative plus 6 electron arrow 2 Cr 3 positive plus 7 H2. So now you can check both side charges are same. 14 positive, clear? 6 negative and 2 negative, that is 8 negative. So 14 positive and 8 negative, that is how many positive are 6, and this side also 6 positive. Now we can balance this one. This is the reduction half reaction, clear, and this is the balanced reduction half reaction. Okay, and reduction means gaining of electron. So see here, in the reactant side we have added 6 electrons. If we balance the equation number 2, that is oxidation half reaction, in the reactant side 2 positive, in the product side 3 positive. It means if we remove 1 electron from this side, or we simply say if we added 1 electron in the product side, so both side number of charges will be same. So see here, Fe2 positive by the gaining of one electron convert into Fe3 positive, and removal of electron is known as oxidation. It means it is a correct oxidation half reaction represent to the balanced oxidation half reaction, and that is Fe2 positive, Fe3 positive and one electron. Clear? Now see here, this is equation number 6 and this is the equation number 7. Now we again added, because both our reactions are the balanced, now we again added balanced redox reactions. Clear? Means reduction half reaction and oxidation half reaction. Clear? But before balancing, first of all, before adding this equation, first of all we see here one electron in this equation and there are 6. It means first of all we multiply by 6 in the equation number 7. 6 Fe 2 positive arrow 6 Fe 3 positive plus 6 electron. So now in both the equation number of electrons are same and we can easily add this equation. So first of all we write these two equations, 6 Fe 2 positive arrow 6 Fe 3 positive plus 6 electron. Now we write this equation 14H positive plus Cr2O7 plus 6 electron arrow 2Cr 3 positive plus 7 H2. Now we added these two. Because both electrons are on opposite direction, it means both are cancelled to each other. Okay. See here, 14H positive only reactant side, not any other side. It means 14H positive. See here, only 6 Fe positive in the reactant side. Cr2O7 2 negative, that is a dichromate ion in this side. Arrow 6 Fe 3 positive plus 2 Cr 3 positive plus 7 H2. So this is the balanced ionic equation, and this equation is balanced by ion electron method. Now we can check each and every atom and charges. See here, how many hydrogen? 14. This side 7 to the 14. Iron 6, this side 6, chromium 2, this side 2, oxygen number 7 and this side also 7. Now we can check the charges. 14 positive and 6, 2 positive means 6 to the 12. So 12 positive and 14 positive, that is 26 positive this side and 2 negative. That is 24 positive on reactant side. This side 6 3s are 18, 18 positive and 3 2s are 6. It means both side number of charges are same, clear, and atoms also same. Now we can further this equation convert into molecular conditions. हमने क्या चीज एलिमिनेट करी थी? हमने सल्फेट आयन एलिमिनेट करे थे. क्लियर? हमने एलिमिनेशन किसका किया था? जो कॉमन था. कॉमन क्या था? सल्फेट आयन. हम सल्फेट आयन को दोबारा से इसमें ऐड करके इसको दोबारा से उसी कंडीशंस में ला सकते हैं जो उसकी मॉलिक्यूलर कंडीशंस थी. क्लियर? सी. So Fe है, there are 6 Fe and FeSO4, 1 Fe contain 1 SO4. It means 6 Fe contain or 6 Fe bonds 6 SO4. Clear? H ion represent to the sulfuric acid with the sulfate ion. 1 sulfuric acid of H2SO4 means 2 hydrogen equal to 1 sulfate ion. It means 14 H positive represent to 7 sulfate ion. It means 7 and 6 means 13 sulfate ions required in the reactant side. It means the same 13 required in the product side. Clear? So in the molecular phase, 7H2SO4. Clear? 7 to the 14, that is 14H. 6 FeSO4. Now we added 7 and 6, 13. Clear? Plus Cr2O7, 2 negative arrow. 6 Fe. In this case, Fe2SO4 whole thrice means 2 required 3. Clear? So 6 required, 2 required, 3. 2 required, 3. So 6 required, 3 into 6 over 2. That is 3 is a 9. Okay. So 6 Fe2SO4 whole thrice, that is the iron sulfate. It means we multiply by 3. Clear? So this is the part of iron sulfate. So 3 is a 9. And how many remainings? How many remains? Because in the reactant side we have added 13 SO4. So remaining is 13 this side, and this side we have added 9. It means remaining is 4. Clear? So now we added 4 are remaining. Cr is present in the form of Cr3 positive. Clear? It means Cr2SO4 whole thrice. So 4 to the 6. Clear? And 2 3 is 6. So remaining is 1, that is the sulfate ion plus 7H2O. So this is the balanced chemical equation in the molecular phase. This is balanced chemical equation in the molecular phase, means 7H2SO4 plus 6 FeSO4 plus dichromate ion plus 3 Fe2SO4 whole thrice plus Cr2SO4 whole thrice plus SO4 plus 7H2O. So this is the balanced chemical equation, and this redox chemical equation is balanced by ion electron method. Clear? In the next video we will discuss about the same redox reactions, balancing of the redox reaction, but by oxidation method. Clear? Thank you, students.